Hello, my amazing students. Today we're doing fractions 20. So we're just marching through our fraction lessons. And today we're doing multiplying fractions and whole numbers together. So my biggest goal with my math curriculum is for you to know and understand the why behind why we do certain things. So I am going to labor over concepts and not just the how to do it, but why we do things the way that we do them, so that things will stick in your brain if you don't just know the processes, but you also know the reason why something is so. Okay, so this one is a really cool one because it teaches you why we multiply fractions and whole numbers the way that we do. Okay, so we're going to start with a very simple problem. 10 times 5/6. Now we've talked about multiplication before, and when we are multiplying, if I was going to multiply 2 times 3, and I was going to say, I want you to write me a picture of 2 times 3, you would say, well, 2 times 3 means 2 groups of 3. So a good picture for 2 times 3 would be 2 groups of 3 items each. And we know that 2 times 3 is 6. When we add up all of the little balls together, we get 6. So 2 times 3 is 6. Now, we can use that same concept when we have fractions. Multiplication doesn't change in its meaning just because we have changed what we're multiplying together. So multiplication 10 times something still means 10 groups of something. Okay, so when we're talking about 10 times 5/6, we're saying 10 groups of 5/6 each, or 10 5/6 added together. Okay, so the long way to do this would be to write down 5/6 10 times and then add them together. Well, we know that addition of fractions, we have to have a common denominator. And once we get the denominator the same, we keep that name. So when we're adding a bunch of 5/6 together here, we're going to have a 6 down here in the denominator. We don't change the denominator once we get that common denominator in each one. But then we're going to add all of these numerators together. So we've got 5 plus 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 5. And we have 10 of them. So 10 5s added together is 10 groups of 5, or 50. So we wind up with 50 over 6. Well, we've done 50 over 6 or something like it. And when we ever have a improper fraction, a bigger number on the top and a smaller number on the bottom, then we can turn that into a mixed number. Okay, so 50 divided by 6 goes 8 whole times. 8 times 6 is 48, so we have 2 left over, or 2 6 left over, which is going to be 8 1/3. We need to simplify that fraction. So 50 over 6 is the same as 8 1/3. So now let's use multiplication instead of that long addition problem. So we're going to take 10 times 5/6, and we're going to change our 10 just to make it easy and less confusing. We're going to change it into a fraction. We're going to make it 10 over 1, so that we know that our 10 is in the numerator and our 1 is in the denominator. When we're multiplying fractions, all we have to do, this is the cool part, we don't have to get common denominators when we multiply fractions. We just write down the numerator times the numerator is 50. The denominator times the denominator is 6. Does that look familiar? Because over here, when we added 10 of the 5/6 together, we got 50 over 6. And then we reduced that to 8 1/3. third. That's how we're going to multiply. When we're multiplying two fractions, we just multiply the numerators together and we multiply the denominators together and we simplify. That's it. Now, in the next lesson, we'll learn some little tricks to do that faster, but this is the reason why. It works. Okay, so we're taking a whole number, we're turning it into a fraction by putting a 1 underneath the whole number, and then we're multiplying. Numerator times numerator, denominator times denominator, and then simplifying our resulting fraction if it needs simplifying. And that is going to be what we're doing. I'm going to come back with some problems for you to work with me in a moment. All right, here we have 6 problems on the board. So I have a whole times a fraction. I'm going to take my whole number and put a 1 underneath it, turning it into a fraction with the denominator of 1. So now I'm going to take my 2 numerators and multiply them together, and my 2 denominators and multiply them together, and I get 6 over 5, which is improper. 5 goes into 6 one whole time, and then 1 is remaining. So that becomes 1/5. All right? And I'm going to turn this 6 into a 6 over 1 so that I can see which one is the numerator. And then 6 times 4 is 24 over 5, which becomes an improper fraction. 24 divided by 5 goes 4 whole times. That's 20. So I have 4 left over and 4/5. Isn't that easy? All right, let's do the next one. Now we have 18 over 1. Now 18 times 5 gives you a pretty big number, and it is 90. Okay, 18 times 5 is 90, and 1 times 6 is 6, and 90 divided by 6 is going to give you 1. And so 6 goes into the 9 one time with what left over? Okay, 30. So then 6 goes into 35 times. Okay, so 15 is the answer. If you don't know how to do that division in your head, don't worry about it. I've been doing this a long time, okay? You'll get there. All right, so 15 is the answer, 15 wholes. And when I come over here and I do this one, I'm going to put the 25 over the 1, and 25 times 2 is 50 divided by 5, and 50 divided by 5 is 10. Okay, and then over here I'm going to put the 50 over 1, and I will get 150 when I multiply the 50 times the 3 divided by the 10. Oh, 150 divided by 10 is just going to be 15. Okay, and the last one here, I'm going to divide by a 1. All right, so 24 times 3 is going to give me a 72 divided by 8, and 72 divided by 8 is 9. Now, what we're going to talk about really doesn't show up for a couple of lessons, but I'm going to show it to you now. We're going to learn how to cancel. Okay, now all of these were correct, but let's start right here, Okay, let's start right here, and let's look at an easier way to do this same problem. We did get the right answer, 15, okay? But remember that if I had a fraction, 18 divided by 6, let's just recall a little bit. If I had a fraction, 18 divided by 6, and I wanted to simplify that fraction, I'm going to divide the top by 6 and divide the bottom by 6, and that is going to simplify to 3 over 1, or 3. Okay, now the cool thing about what happens when we multiply two fractions together is there's a little intermediate step. Okay, so here 18 times 5 is 90, but I could have written that as 18 times 5 on the top and 6 on the bottom, okay? So notice that I could have written it as one fraction with, instead of putting 90, I could have put 18 times 5 up on the top. And if I didn't want to use my little times dot, I could have done this. Okay, I could have just written 18 times 5 in parentheses. But notice when I have it all in one fraction, then it becomes apparent that, oh, I've got an 18 on the top and I've got a 6 on the bottom. I could divide that fraction by 6 over 6. So if I divide this by 6 and this by 6, then all of a sudden that 18 becomes a 3 and that 6 goes to a 1, and I wind up with 3 times 6 is going to be 3 times 5. Excuse me, 3 times 5. This is gone because we divided this. 3 times 5 is 15. Okay, so what we're going to do, because these two will eventually be together in one fraction, is we're going to cancel. Anytime we see something in the numerator and something in the denominator, we can cancel those. So, to make this easier, it is 15, but I had to think, oh, 18 times 5 is 90. I had to come up with a bigger number. What if I, oops, sorry about that. What if I looked at this and I said, okay, I'm going to recognize that this 18 is going to wind up in the top of the fraction, and this 6 is going to wind up as a factor of the denominator, and I'm going to say, oh, they both divide by 6. Therefore, when I divide 18 by 6, I get 3. When I divide 6 by 6, I get 1. And now I can skip this step, and I can go straight to 3 times 5 is 15 over 1. And 15 over 1 is 15. Isn't that a cool shortcut? That's called cancellation. Okay, now let's look over here. Keep on falling off there. Okay, let's look at these. And let's look at this one and say, would there have been a cool shortcut so that we never had to do the big stuff? We just got straight to our answer. And the answer to that question is yes, there is. You see, we have a 25 in the numerator of one fraction, but in the denominator of the other fraction, we have a 5. And 5 and 25 have a common factor of 5. So what I'm going to do is I'm going to divide by 5, and I'm going to divide by 5. Oops, 5 divided by 5 is 1. All right? So now look what happens. 5 times 2 is 10. 1 times 1 is 1. 10 over 1 is 10. Isn't that easy? All right, now let's look at the next one. Is there a way that we could have made this easier and not have to go to these big numbers? Well, 50 and 10 both divide by 10. One is in the numerator, one is in the denominator. That fills the requirements for cancellation. So I'm going to divide this one by 10, and I'm going to divide this one on the bottom by 10, and now 5 times 3 is 15. 1 times 1 is 1. 15 over 1 is 15. What about this one? Do you see something that might cancel here? We had to come up with some pretty big numbers. Okay, could we have made it easier? 24 and 8 both have 8 as factor. So 24 divided by 8 is 3. 8 divided by 8 is 1. 3 times 3 is 9. 1 times 1 is 1, and a 1 on the bottom just makes it a 9. So we're going to work some more with multiplication of fractions. But this is the end of fraction 20, and this is Mrs. Carla, and may God bless your day.